So far, we've done one substance conversions, and that's using this map. So if we have H2O, I can tell you, if you give me grams, how many moles there are, or how many atoms there are, or if I'm given one of these quantities, I can find the other. We're moving on to stoichiometry now, and our next map looks very similar to this other map. Notice we have moles in 1, 2, 3. So if I look right here, I have the same map, moles 1, 2, 3, and it's for only one substance. Now I can put two maps together and I can convert from substance A to substance B in a balanced equation, and that's stoichiometry. And so we are going to focus today on what connects these two maps, which is moles of substance A to moles of substance B, and we are going to relate these using a coefficients from our balanced equation, and we call that a mole ratio. And this is going to be your conversion factor to go from moles of substance A, one substance, to a different substance in a balanced equation. And these numbers here tell you how many moles. So if you have 2 moles of H2 gas, you can make 2 moles of water if you have plenty of oxygen. If I only have 1 mole of oxygen, I can make 2 moles of water. If I have plenty of hydrogen, I need at least 2 of them. So let's take notes on that. Stoichiometry. I'm going to zoom in a little. And stoichiometry literally means element, stoich, and measure, metry. So it's the measuring of these elements. And we are going to calculate the amount of products or reactants in a chemical reaction. So here's our reaction, and we want to think about this like a recipe. So if I have, let's think about this in terms of food. If I have 1 egg and 2 cups of flour, I can make 2 pancakes. The only difference is we're using hydrogen and oxygen, and we're making water. Now, to understand how many eggs per cups of flour, you need to know what those numbers are to make the right recipe, and that is our balanced equation. So if you don't have this balance, you won't have the correct recipe. Okay? And so what we have here, if we just read this out loud, you can say we have 2 molecules of hydrogen and 1 molecule of oxygen, and makes 2 molecules of water. But we count things in chemistry in moles, and that's just a multiple. So we have 2 moles of hydrogen and 1 mole of oxygen will make 2 moles of water. Now I can double a recipe just like I do for chocolate chips because I have 3 boys and I need a lot. And if I doubled it, I'd have 4 moles of water to 2 moles of oxygen. If I combine those, I'll make 4 moles of water. Notice this is a 2-to-1 ratio. It's still a 2-to-1 ratio. I just doubled the whole thing. So those coefficients show the ratio of chemicals in a balanced chemical reaction. Okay? And these ratios are what we're going to use to convert from the moles of one substance to moles of another. So you can write any ratio you want here. I have 1 mole of oxygen to 2 moles of hydrogen. Where did I get that 1 and 2? Right here. 1 mole of oxygen to 2 moles of hydrogen. Or I could have 2 moles of hydrogen to 2 moles of water. And if I reduce that, you see that's a 1-to-1 ratio. I can have 2 moles of water to 1 mole of oxygen. Okay, so I just have a few written here, but you can write any way you want. And how are you going to know which way to write that? Well, we have to set up our conversion factors just like we did doing our conversions with one substance. We are going to write our given. We're going to put what we our given units on the bottom to get rid of them and put what we want on top. Okay, so we are going to use these mole ratios to convert the number of moles of substance A to number of moles of substance B. And that is this part, which is the true part of stoichiometry. Now, just to give you a heads up, suppose I don't give you moles, I give you grams. Well, then I take grams and I convert it to moles, just like I do here, and then I can use my mole ratio to get to another substance in the balanced equation. Okay? So, for instance, how many moles of hydrogen gas are needed to produce 3.9 moles of water? So this is our given. We write down our given, 3.9 moles of H2O. I get rid of my given units, which is H2O on the bottom, and I want to go to hydrogen gas. That's what I want. Where did I get these numbers? This is my mole ratio because I'm comparing moles of one substance to another substance in a balanced equation. 2 with H2 comes from this right here. 2 with H2O comes from that right there, and that is my mole ratio from the balanced equation. And like always, I multiply by what's on top, I divide by what's on the bottom, and since that's a 2 to 2 or a 1 to 1 ratio, I have the same answer. So if I have 3.9 moles of water, okay, how much hydrogen is needed to make that water if I had plenty of oxygen? 3.9 moles. 2 to 2, 8 to 8, 3.9 to 3.9. Okay. How many moles of H2O are produced from 2.4 moles of oxygen? Now, when they give you these problems, you're going to assume that there is plenty of the other chemical to react completely with it. Okay, so 2.4 moles of oxygen are given. I don't want moles of oxygen anymore, so I'm putting it on the bottom. And I'm going to H2O because that's what they asked for. And now I'm just going to plug in my coefficients for my balanced equation, which is my conversion factor. H2O, here it is. Whoop, that has 2, so 2 goes there. Oxygen, that has 1, so 1 goes there. Okay, so we're going from moles of A to moles of B, and we're using those coefficients from the balanced equation.